Hello, this is Tahsin from Roots of Unity, and today we'll be going a little in depth about invariant lines, and we'll also discuss about some three-dimensional transformation matrices. Last week we did talk about invariant lines, and we said that every point on the invariant line is mapped to the point itself. But that isn't entirely correct. The true definition of an invariant line is that an invariant line of a transformation is one where every point on the line is mapped to a point on the line itself. So you see, the definition we used on the last video is still technically correct. Because if a point is mapped on the point itself, then it still lies on the invariant line, isn't it? The point that's being mapped still lies on the invariant line, right? So you see, there are actually two scenarios. The first scenario is when the point is mapped on the point itself. The point is being mapped on the point itself. And the second scenario is when the point lying on the invariant line is mapped somewhere on the invariant line. The first scenario occurs when there is only one invariant line, only one. And the second scenario occurs when there are two or more invariant lines. Yes, that's right. A transformation matrix can have more than one invariant line. For example, the transformation matrix minus 2, 0, 0, 1, this is a stretching matrix, has only one invariant line, which is the y-axis, or x equals to 0. And every point on that invariant line is being mapped to the point itself. You see, none of the points here is being moved. It's lying, it's not being translated, it is where it is. It's being mapped to where it was. And the matrix 1, 2, 2, 1 has two invariant lines. We can see here the invariant lines are y equals to minus x and y is equals to x. And every point on the invariant line is being mapped on the invariant line. And then the matrix, the rotation matrix 0, 1, minus 1, 0 does not have any invariant line, but rather it has an invariant point. Yes, there can also be invariant points. And the definition of an invariant point is that it is a point which does not move when a transformation is applied on it. So the invariant point, any point on the invariant point, is mapped on the point itself. Now that we know more about the behavior of invariant lines, it brings us to the question, how do we actually find out invariant lines of a matrix? There are actually two methods to find out the invariant system of a transformation matrix. The first method can be used to find out the invariant systems of matrices that have either only one invariant line or an invariant point. And the second method can be used to find out the invariant system of a transformation matrix which has either one invariant line or two invariant lines. In the first method, first we write down the matrix, and beside it we write down multiplied by xy, x referring to the x coordinate of the point and y referring to the y coordinate of a point. And then we write down is equal to xy. And what this means is that this matrix is mapping this point on the point itself. And when does this happen? This happens when there is only one invariant line for this matrix, or if there is an invariant point for this matrix. And so this method is used to calculate an invariant line or an invariant point for the matrix. So let's try to find out the invariant system of this matrix 0, 1, minus 1, 0. And the way to do this is writing down this matrix beside xy is equals to xy. And then we multiply this and we get two equations, minus y equals to x and x equals to y. We get two inconsistent equations. You might think that these two equations are the equations for the invariant lines for this matrix. But as we said before, using this method you cannot find out the invariant lines of a matrix, but rather you can only find out one invariant line. Not two, not three, only one invariant line can be found out using this method. You can also find out a point and one single invariant line. So when you get two inconsistent equations using this method, What you have to do is you have to substitute these equations and solve it. So after substituting, we get minus y equals to y, which gives us y is equals to 0, and therefore x is equals to 0. So we get the coordinate 0, 0 as the invariant system for this matrix. However, this might not be the final answer, because there is a possibility that this coordinate isn't the invariant point for this matrix, but rather is the coordinate of intersection of the two invariant lines of this matrix. This coordinate may be the point of intersection of the two invariant lines of this transformation matrix. So what you have to do is you have to use the second method on this matrix, on this transformation matrix, to really find out that whether this transformation matrix only has one invariant point or that it has two invariant lines. So how do we perform the second method on this? So how do we perform the second method? Firstly, we write down the matrix, and then beside it we write down multiplied by the coordinate m and mt. Why? Because every invariant line of a matrix has the equation y is equals to mx, where m is the gradient of the invariant line. So if the value of x is t, then the value of y is mt. So this is basically the x coordinate and this is the y coordinate. And then we say that this is equals to capital T mt. And this basically means that this matrix translates this point somewhere on the invariant line. That is why this point is defined as T and mt. And this method allows us to find out one or two invariant lines for this matrix, but not an invariant point, due to the definition of this equation. So let's apply this method to that matrix before, to find out whether that matrix actually has an invariant point or whether it has two invariant lines. So we write down this matrix, and beside it we write down a T and mt, and we multiply this, and the result would be T and capital T and mt. So we get two equations: minus mt is equals to capital T and T is equals to m capital T. So what we do is we divide this with this to get this result: minus m is equals to 1 by m. Then we simplify this and get the result as m is equals to root over minus 1. And thus, since the gradient is imaginary, therefore this equation has no invariant lines, and thus the answer we got previously, the coordinate we got previously as our answer using the first method, is the actual answer. The invariant system of this matrix is actually only an invariant point at 0, 0. So finally, let's try to find out the invariant system of this matrix: 1 minus 2 minus 2 1. So we write down this matrix, and beside it we write down xy is equals to xy. So we're using the first method, right? So what we do now is that we multiply these, and then we get two equations: x minus 2y is equals to x, and minus 2x plus y is equals to y. Then we simplify both these equations, and this equation simplifies to y is equals to 0, and this equation simplifies to x equals to 0. So we get a coordinate as our answer, which is 0, 0. So now remember that we said that there is a possibility that this matrix does not only have an invariant point as its invariant system, but rather the answer we got here using the first method may be the coordinate of intersection between the two invariant lines of this transformation matrix. So what we have to do is, just to be sure, we have to use the second method on this transformation matrix. So doing it now, we have 1 minus 2 minus 2 1 multiplied to T and mt is equals to capital T m capital T. So we multiply and we get two equations. We get T minus 2mt is equals to capital T, and minus 2T plus mt is equals to m capital T. So what we do now is that we divide the first equation with the second equation, and then we get only one equation, which is 1 minus 2m minus 2 plus m is equals to 1 by m, and then this simplifies to m squared is equals to 1, and we get m is equals to plus minus 1. So we do get a value for m. Therefore, the answer we got previously, the coordinate 0, 0, wasn't our answer, but rather this is. This equation, this matrix has two invariant lines. One is y is equals to x, and the other is y is equals to minus x, since the gradient is plus 1 and minus 1. And this is our actual answer. This is the coordinate system. These two invariant lines are the invariant system for this transformation matrix. So my advice for solving questions which ask you to find the invariant lines of a transformation matrix would be that you perform the first method on the matrix first, and if you get a coordinate as your answer, then and then only do you perform the second operation, the second method on that transformation matrix, because you know the second method is a little bit tedious. So first off, you perform the first operation, and then only if you get a coordinate as the answer, then and then only would you use the second method on that matrix to get an answer. And that's gonna be all for this video. Hope you guys liked it, and I'll see you guys in the next video. Till then, stay tuned and stay curious. Signing off, Tahsin.